18.7. Okay, this will be the last method to prepare the salt. The salt that we're going to talk about this time is insoluble salt, and the method is precipitation. So preparing insoluble salt, okay, first of all, remember you have to follow, okay, the solubility tables. Okay, it tells you which one will be soluble salt, which one will not be a soluble salt. Most common insoluble salts that we have will be like AgCl, like Pb2, okay, something like Ca2 sulfate, calcium sulfate, things like that, okay? And also for most of the carbonate, they will be insoluble as well. So maybe you have like Ca2 carbonate, magnesium carbonate, things like that, okay? So our previous videos, we have already talked about two methods. The first one, okay, we have put excess metal oxide into acid. Remember that? Okay, this is acid and this is metal oxide. The second videos that we've talked about, that will be the titration setup. So this time, okay, we simply mix two solutions. So we have one solution and then with another solution, you just pour them together and the insoluble salt will form immediately. So preparation of insoluble salt, okay, you can see that, okay, right here we have two solutions. One is lead-2 nitrate. Lead-2 nitrate is a solution form. That means that in this liquid, okay, we will have Pb2 plus and also with nitrate ion. Because NO3 minus, okay, nitrate ion solutions, okay, it must be soluble. So for lead-2 nitrate, when it dissolves in water, they will form mobile ion in it. So same happened to the sodium sulfate solution. So in this case, okay, each of them, they will carry a cation and anion. Okay, when we mix them together, okay, we will have like Pb2 plus, with Pb2 plus, Na plus, sulfate ion, and also have nitrate ion. When they come together, you'll find that, okay, the lead-2 sulfate, because they can form insoluble salt, they will quickly group together to form lead-2 sulfate. Okay, so the lead-2 sulfate will then become the white precipitate. So all the lead-2 ion and sulfate ion, they will just stick together, and this process will be pretty fast. Okay, the textbook suggests you to stir a bit, but actually you just mix them. Okay, that will be all right. Okay, but one thing you have to remember, these reactions, okay, must be occur between two solutions. Later on, I will tell you why it have to be like that. Okay, so if you want to see, okay, the reactions, how fast it will be, you can just go to this QR code, okay, and have a look of it. Okay, so so in this case we have lead-2 nitrate and also sodium sulfate. Both of them are aqueous state, but when they have a precipitation, the lead-2 ion and sulfate ion, they will combine and become solid. So one of the salt will become solid, okay, and then leaving behind, okay, the nitrate ion and also sodium ion, they become sodium nitrate, but they are still in aqueous state. So if you try to write Ionic equation, most of the time we will write Ionic equation for that. The one really participate in the reaction, which will be the lead-2 ion, sulfate ion to become lead-2 sulfate solid. So your task, okay, is to suggest the solutions. Okay, I would say that this method like finding parents. Now, okay, I will have the kids. Okay, that is lead-2 chloride. I need to find out, okay, the papa and mama. Okay, so what are they? So insoluble salt, basically, okay, these two ions. Okay, we have like Pb2 plus here. And then you have chloride ion here, right? They must be, each of them must come from, okay, one solution. So for the cation one, okay, basically what you need to do is just add nitrate will do. So for Pb, then that will be PbNO3 bracket 2. And for the anion part, okay, for the anion part, you just need to add Na in front of it. So it will be NaCl, okay? So these two can be prepared for aqueous solution for sure, because both of them, one of them they contain nitrate, one of them they contain sodium ion, and we did mention before these two ions, okay, must be able to form soluble salts. They must be able to dissolve in water. So remember, ionic compound with these three ions, okay, must be soluble in water. Okay, so therefore they must be able to become solution. So we use the same method, okay? So with barium, which is Ba2 plus, with a sulfate ion. So what you need to do is just add Ba okay, with nitrate, that will be NO3 bracket 2. Sulfate, you just add sodium ion in front of it, so will be sodium. Because sulfate is 2-, so therefore will be Na2 SO4. So both of them will be in aqueous state. Okay, and the last one is calcium carbonate. So it is calcium nitrate and also sodium carbonate, or you use potassium carbonate will also be all right. Okay, so this is how we suggest when the question say, oh, I want you to prepare lead-2 chloride, then you just tell them that, okay, we can use this solution and mixing these solutions, and then we can form the lead-2 chloride. So remember, okay, some of the reaction is feasible. Feasible, it means that, okay, in this case, okay, the feasible one, okay, must be having both of the solutions, okay, are both of the chemicals in aqueous form. Both of them are solution. So just now, okay, will be like this way. Why they have to be in solution? Because in solution, they are already in mobile ion. Say, for example, the second one, silver nitrate and also sodium chloride. Before we mix them, they have to be in mobile ion. Once we mix them together, they will be come together. We say, for example, sodium chloride, they will stick together to form the precipitate. If it is not aqueous, it is a solid. Say, for example, I just changed this state symbol. Before dissolving in water, okay, they are solid. If I do this one, okay, then that will be a problems. Okay, so for the solid one, okay, the problem is when the lead-2 nitrate get into the solutions, the lead-2 nitrate get into the solution, okay, they will start to dissolve. So the Pb will come out, the Pb2+. But once it come out, okay, it is surrounded, okay, by a lot of sodium sulfate solution. So the sulfate ion will be around. So they will immediately form with the lead-2 sulfate, and then slowly, okay, they will form the lead-2 sulfate around the solid. So if we do that way, okay, the sodium nitrate, the lead-2 nitrate inside cannot dissolve out into the solutions anymore. So after a while, you will find that the PbNO3 will be inside, and then the newly formed lead-2 sulfate will be outside. So it will be surrounding, okay, the chemicals, and then it will prevent the reactions to continue. Okay, so same thing happen if I have sodium chloride but silver nitrate. If this one is solid state, so same thing happen. Okay, the silver nitrate, it will start to dissolve. However, after they dissolve, the Ag plus coming out, they immediately formed precipitate with the chloride ion. So the chloride ion, the silver chloride will then form on the surface. Is surrounding it. Okay, so not only this, okay, but some of the reaction we have learned before, say for example, calcium are added into sulfuric acid. So for the product form is calcium sulfate, which is insoluble. So we will surround the calcium, not allow the calcium continue to react with the acid. And same thing happened to the carbonate. Okay, so the calcium carbonate will be surrounding it. Okay, the calcium sulfate will surrounding it. So the calcium sulfate will surrounding it. So therefore, you will find that the chemical inside cannot have further reactions. So the main point is the solid newly formed, they will wrap around the reactant and prevent further reactions. Okay, so you'll find that, okay, in order to have preparation of insoluble salt, you must ensure that both of the solutions, both of the chemicals are in solution form. So experimental procedures, okay, like what we've done, we're mixing one solution into another one. So once we mix, okay, the precipitate will form. So what we need to do is just mix two solutions. After the precipitate form, okay, what you need to do is just filter, wash, and dry, okay. But this time, okay, the washing, can we wash with large amount of cold water? The answer is okay, because this time we are preparing insoluble salt. So even you use a large amount of cold water to wash it, it can only bring away the soluble impurities. Okay, they just remove the soluble impurities. But the newly formed insoluble salt cannot be dissolved and washed away. Okay, so for this experiment, okay, you have to learn the sketch of the filtration. Actually, we've talked about this a few times. Okay, after you get it, or after you get the precipitate, okay, you wash it, okay, and then you dry it, okay. So procedures is pretty easy for this. First of all, okay, not first of all, okay, one thing very, very, very important, okay. Normally the public exam, they try to set trap, okay, to you for this, okay. They will ask you to prepare a salt. Say for example, they will ask you to prepare lead-2 sulfate precipitate, okay, and then they say that, oh, I have given you lead-2 nitrate solid, okay, so suggest another chemical to react, okay. Then you may say, oh, I got lead-2 nitrate solid, okay, I just dump it into, say for example, sodium sulfate solution, okay. If you do that way, okay, then they will you will have done, okay, the problem that just now I've mentioned, okay. Remember, you never add solid into solutions, okay. If you do that, okay, even like filter, wash and dry, all the things statement behind is correct, okay, because the reaction is not visible, you will score 0 mark for this for sure, okay. So step 0 is, okay, if you're given a solid things, okay, dissolve it into the water first. This is the most important step. After that, okay, you just mix solution A with solution B together, and then filter the precipitate, wash the precipitate with large amount of distilled water, and then dry it with filter paper or oven. Okay, so this is the procedures. It's pretty easy comparing to the first two method. Okay, so examples. Name 2 aqueous solutions used to prepare the salt, okay, and then write down the chemical equation and another equation. So basically, copper 2, so will be Cu nitrate, and then carbonate, that will be sodium carbonate. Ionic equation, I just write ionic equation, okay, for the rest, you just do it on your own. So copper 2 carbonate, actually, you just add them up together, will do, okay, CuCO3, so this one is solid, aqueous, and aqueous. Okay, and then for silver iodide, that will be silver iron, iodide, iron to get NaI, which is solid, and then these are the aqueous. So for the salt, okay, will be called silver nitrate. Remember, when you're finding parents, okay, cation find nitrate, okay, and then anion, you add sodium ion in it, okay. So these are the 2 aqueous solutions that you need, okay. So suggested method for preparing a particular salt, okay. So basically you classify them into soluble salts without Na+, with Na+, and also insoluble salts, okay. So say for example, this is called titration, this is called mixing the solution, this one is metal oxide, okay. So calcium carbonate, carbonate must be insoluble most of the time, I mean. So this is insoluble salt, we are using mixing solution, method 3, okay. And then ammonium nitrate, okay, ammonium nitrate, okay, that is the titration one, because it's a soluble salt with K plus Na plus and NH4 plus. Copper 2 chloride, okay, copper 2 chloride, they are chloride, most of the time they are soluble salt, but this one without Na plus, K plus, NH4 plus. So this one we use metal oxide one, okay, basically you have CuO plus HCl. Okay, aluminium sulfate, most of the sulfate are soluble. So this one is also soluble salt, but without Na plus, K plus, NH4 plus. So again, aluminium oxide with sulfuric acid. That will be the chemicals, okay? So this one will be NH3 with nitric acid. And then calcium carbonate, that will be calcium nitrate, so therefore they can be soluble. Carbonate, you need sodium carbonate, that is for them to prepare aqueous solution, okay. So this exercise is very important. If you find that I'm talking too fast, okay, please revise and do it one more time on your own. Okay, and then write chemical equation and ionic equation for preparing the following salts. I'm not going to do this anymore, okay, so please go back and try it out on your own. Just the second question, in each of the following cases, judge whether the equation is practicable. That means they can be done or not, okay. So the first one, hydrogen carbonate. Hydrogen carbonate must be soluble salt, okay. Soluble salt, you need acid with a metal oxide, but you can see that they are not having this. So A is wrong because you find that this is aqueous solution, aqueous solution, aqueous solutions, and aqueous solutions. You cannot separate this magnesium hydrogen carbonate. Oh, this S we're talking about soluble. We're not talking about this is solid. So you have all the ions in it, they're mixing well. Say Mg2 plus, HCO3 minus, Na plus, and Cl minus. They're not going to group together to form solid, so they're just random swimming in the solution. So in this case, actually, it is impossible for you to filter them off. Second one, part B. Part B, magnesium carbonate, with acid. So what we are forming, we have magnesium nitrate. So this one, again, it is a soluble salt, no Na plus, K plus, NH4 plus. So we need a metal oxide with an acid, or we can make a metal carbonate. This is also feasible, So B is correct. C, we have insoluble salt. Insoluble salt, remember, must be aqueous. So obviously, part C is wrong. But this one will be slightly different from what we have explained previously, because this time we put lead-2 sulfate in it. Remember previously we say that the lead-2 blah 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 will dissolve out and then they react and form an insoluble solid on the surface. That one is different from this because for that one we're talking about lead-2 nitrate and they give out Pb2 plus and they combine to form an insoluble salt on the surface. But this one cannot dissolve because take a closer look. This one is it itself is an insoluble salt already. So therefore, this one cannot dissolve to give out Pb2 plus, and not to mention to combine with the chloride ion. So part 2C, that is impeccable, because lead-2 sulfate is insoluble. Lead-2 ions cannot combine with chloride ions. Lead-2 ions in a solid state cannot combine with the chloride ions. So last one, that will be a very typical questions, for this sections, That will be describe how to prepare sodium chloride from silver nitrate, This one, they didn't say is solid or not. If it is solid, do remember, dissolve it in water to give aqueous solution first. So to summarize, we have learned about precipitation reactions. So mainly we focus on the ionic equation, and then you have to learn about finding parents. So if you have, say for example, you have silver bromide, you want to find this one. So silver, you add nitrate ion to it, where bromide, you add sodium ion to it. So that will be a finding parents. Remember, both of them have to be in aqueous state. Not feasible reaction is the solid one plus aqueous one. Normally it is not working. Finally, you have to prepare and purify and separate the salt. Normally what you need to do is just mix 2 solution, filter, wash, and dry. But this kind of washing, this time it can be used large amount. But for the previous two, you can only use small amount. So for chapter 18, the most important things will be these 3 methods to preparing salt. Do remember, if you don't know how to classify the salt into soluble salt or insoluble salt, do spend time on this table. This table is very, very important. So we have already finished talking about the titration, mixing solution, and also we have excess metal oxide and add into the acid. So these 3 can be asked in essay type questions. Do prepare that. So that's all for this video. Bye bye.